In this video, we're going to look at some exact values, how to find exact values of different trig ratios of sine, cosine, and tangent. So first of all, you just have to recall something that we talked about in one of the first videos on trigonometry, just about that if you've got some angle here, we've got t, so we've gone positive t degrees or radians, whatever it is, around, and if we have our point there where it ends up on the unit circle, we know that the x value is cos of t and the y value is sine of t. So we need to remember that. Now, if we do remember that and we think about, well, this is a unit circle, right? So the radius is 1. So here that's 1, that's minus 1. Down there's minus 1 as well. So any radius you go around, you're going to be 1. So in terms of your x and y intercepts, they're pretty easy to find, right? For a circle of radius 1 centered on the origin. So knowing that about sine and cos, that the x and y values just give, well, x gives cos of the angle and sine gives, the y value gives sine of the angle. You can get some exact values pretty easily, right? So for example, if t is 0, so we're just flat on the x-axis here, well, I know that cosine is just going to be 1. So cos of 0, 0 degrees, 0 radians, it doesn't actually matter in this case, is 1. And sine, well, the y value of your x-intercept there, it's 1, 0, right? So sine of 0 is 0, yeah? Then as we keep going around, so once we're up at 90, right, we've actually just reversed those. So we're at 90 degrees or pi on 2 radians. So the x value is 0, and the y value is 1. So cos of 90 is 1, sine of 90, sorry, cos of 90 is 0, and sine of 90 is 1. So you could just do that for all of those kind of easy ones where you go to the intercepts. So 0, 90, 180, 270, and then when you get to 360, you're back up here at 0. Then if you have all of these sine and cos values for each of those, you can just put them into your formula for tan, that tan of theta is sine theta divided by cos theta. And if you think about it, so 0 divided by 1, that's just 0. 1 divided by 0, well, you know, we can't really divide by 0, can we? So we just get undefined. Tan of 90 degrees or pi on 2 radians is undefined. And you get similar behavior as you go around. So that's great. We've got some exact values where you get exact answers for your sine, cos, and tan. You might notice, say you put in to your scientific calculator or your CAS calculator something like sine of 17 degrees, you're going to get something that is not exact. It either will just tell you, say it's a CAS calculator, or it might just give you back sine 17 degrees. Or if you tell it to give you decimals, it will just give you some decimals that seem to have no pattern. Now, there are actually some other exact values that we want to know, that we want to recall. So when we're doing things like solving trig equations, that they're going to come in handy. And I'm going to show you how to remember them. They're based on two special triangles, which I'll show you how to get them. So one of them is an equilateral triangle. So equilateral triangle of radius 2. So if that's 2, and that's 2, you might recall that with equilateral triangles, every angle is 60 degrees. I'm just going to do this in degrees because, yeah, you can just go to radians from there, and it's not too hard, really. Now, if you look at this, so that top one's also going to be 60 degrees, but there's no right angles there, so we can't do any right angle trig yet. But if we split down from the middle and make that, so we know that's a right angle, right? And we've split that 60 degrees exactly in half. So that is 30 degrees, yeah? Now, if I split it exactly in half, this distance from here to the middle must be 1. If you then do a bit of Pythagoras, you can get that this height value, it turns out that it is root 3. And then you can just do SOHCAHTOA to get all your exact values for sine, cos, and tan of both 30 degrees and 60 degrees. So for example, if I wanted to do tan of 30, I could just go, all right, well, here's the angle I'm interested in. So the opposite of that is 1, and the adjacent is root 3. So tan 30 is 1 on root 3, which you might see written as root 3 on 3, just being, what would you say, rationalized. Now the other one, so just to recap with that special triangle, all you really had to remember was you had an equilateral triangle of side length 2, and then you split it down the middle, so you get that right angle triangle in there, and that's what you're going to use. So that's really all you have to remember. From there, you can just kind of work it out. Things like, oh, well, I know half of 60 is 30, things like that, and it all kind of comes together quite nicely. The other one, all you really have to remember is I'm going to have an isosceles triangle of side length 1. The two equal sides are 1, and that's a right angle. Now, if you think about it, I know all angles in a triangle have to add up to 180. So if this angle's 90, and with isosceles, those two ones on the end, they're the same value. So there's only 90 degrees left, and so it's got to be half of that, i.e. 45 degrees. Both of them are 45 degrees. And then if you do a bit of Pythagoras, you end up getting that this hypotenuse is root 2. So now if I want to do something like, say, cos of 45, I can just go, all right, well, I'll just say, look at this one, doesn't actually matter which one, but adjacent to that is 1, and the hypotenuse is root 2. And so cos of 45 is 1 on root 2. You can rationalize it if you want, it doesn't matter too much. So here are those triangles drawn a bit more neatly, but we can use them to get all the exact values that we're interested in, really, apart from 0, 180, 90, 360 that we've shown before. These are kind of the main ones. So ones to do with 30, 60, and 45.